Why is it important to beware of excess electrostatic buildup when working with computer equipment?
If you have ever installed a circuit board or card into a computer, the product probably was shipped in a static-free bag. This bag is designed to keep all excess static charge outside the bag. Many electronic circuits are sensitive to the electrostatic buildup and can be damaged if such a charge accumulates on sections of the circuit.
How can the refraction of light be determined?
The extent to which a beam of light bends when it hits a different medium depends on the indices of refraction of the medium as well as the medium from which it came and the angle at which the light strikes the boundary between the two media. All materials have an index of refraction that depends on the speed of light in the material. The index of refraction is the speed of light in a vacuum divided by the speed of light in the material. A vacuum has a refractive index of 1, water is 1.33, and glass is around 1.5. The higher the index of refraction, the more slowly light travels through the medium. Snell's law of refraction, named after Dutch physicist Willebrord Snellius, 1580 to 1626, tells us how light behaves at a boundary between two different media. Consider the interface between two media where the refractive index of the top medium is lower than that of the bottom medium. According to Snell's law, when light hits the boundary between two materials, it is bent from its original path to a smaller angle with respect to the line perpendicular to the surface of the interface. As the incoming, or incident angle increases, so does the refracted angle. When light goes from a medium with a higher refractive index into one with a lower index, then it is bent away from the line perpendicular to the surface.
How was the connection between electricity and magnetism discovered?
The close connection between electric current and magnetic fields was discovered quite by accident. In 1820, Danish physicist Hans Christian Ørsted, 1777 to 1851, gave a lecture on the heating effects of an electric current on a wire. A compass happened to be near the wire and he was surprised to see the compass rotate when the current was on. He had been looking for connections between electricity and magnetism for several years, but expected that the compass would point away from the wire. Instead, he found that the compass pointed in a circle around the wire. Above the wire it pointed perpendicular to the wire. Below the wire it also pointed in the perpendicular, but in the opposite direction.
Is there such a thing as a completely circular rainbow?
All rainbows would be completely round except that the ground gets in the way of completing the circle. However, if viewed from a high altitude, such as an airplane, circular rainbows can be seen when the angle between the sun, the water droplets, and the plane is between the 40 degrees and 42 degrees. In this case, the rainbow is horizontal, meaning that it is parallel to the ground and therefore not blocked by the ground. This is quite a sight.
Why would you need to know the time this accurately?
Businesses that use computers in many parts of the world can synchronize their computers so that the precise time that transactions occurred are known. GPS also provides navigation information. Hikers use GPS to replace maps, which are often outdated, compasses, and lists of landmarks. Automobile and truck drivers use GPS to replace paper maps and to find local businesses, such as banks, restaurants, and gas stations. Farmers use GPS to map precise locations in their fields. Not only does this information improve planting, it can be used to mark the locations of areas that need additional insect control chemicals or fertilizers. Engineers are now working on GPS systems to improve the flow of automobile traffic and reduce crashes. Each car would have a GPS receiver that would then broadcast its position. This information could be used to change red traffic lights to green if there were no opposing traffic. If two cars were equipped this way, the system could determine the distance between them and their relative speeds. If they were on a collision course, the system would apply the brakes to avoid a crash.
What is a watt?
A watt is the unit of power, or the rate of energy transfer. Light bulbs, toasters, hair dryers, televisions, and other electrical appliances are rated by the power they use. In the context of electricity, the watt is the unit for electrical power and is often found on light bulbs and other devices used in electrical circuits. The formula to find the power used is P equals I x Vt, power equals current times voltage.
What is an inelastic confinement?
In a collision, the kinetic energy of colliding objects is smaller after the collision than before it.
Are there non-contact field type forces other than gravity?
Both the electric force between charged objects and the magnetic force between magnetized objects can be described as the force caused by an electric or magnetic field caused by one object on the charge or magnetic moment of the second object.
What is a nuclear reactor?
Method of producing electric power where energy released by nuclear. Fission is used to boil water producing steam that turns generators.
What are primary colors?
Blue, green, and red of light, cyan, magenta, and yellow of pigments.
What is a wheel and axle?
Simple machine. If the radius of the axle is A and the radius of the wheel is W, then if the input force is applied to the wheel, the output force is given by Foutput equals Fput, with A.
What is a concave mirror?
Curved inward so that the incident rays of light are reflected and can be brought together. Can form real or virtual images.
What materials make the strongest permanent magnets?
Traditional permanent magnets were made of an alloy of aluminum, nickel, and cobalt, called alnico. Ceramic and rubber magnets use ferrites, an iron oxide material. In the 1980s, the automobile companies searched for materials to reduce the weight of motors in their cars. They found an alloy of cobalt and samarium, a rare earth. Made strong, lightweight magnets, but were extremely brittle and expensive. Today the strongest magnets are made from a lanthanum iron boron, Lib, alloy. Their strength can be as much as 20 times that of iron magnets. They are also brittle and so are coated with a plating of nickel and copper. Their price has fallen so much that they are used to hold sunglasses to eyeglass frames, in necklace clasps, and in children's toys.
How far away was that lightning?
When a lightning bolt goes from cloud to cloud or cloud to ground, it suddenly heats the air through which it passes. This sudden increase in temperature causes thunder that occurs at the same time as the lightning. Although it takes virtually no time to see the lightning. Depending upon the observer's distance from the lightning, it can take quite a while to hear the thunder. The speed of sound at room temperature is about 1,100 feet per second. A mile is 5,280 feet, so it takes about 5 seconds for sound to travel 1 mile. So, to determine how far away lightning has struck, when you see the lightning, count the number of seconds it takes before hearing thunder. Divide the number of seconds between the lightning and thunder by 5. To determine how many miles away the thunder and lightning occurred. For example, if you see a flash of lightning and approximately 10 seconds later you hear the thunder. Divide the 10 seconds by the 5 seconds per mile to find that the lightning occurred 2 miles away.
What is a pulley?
Simple machine. A fixed, or unmovable, single pulley can be considered a wheel and axle where both have the same radius. The mechanical advantage is 1, but the pulley changes the direction of the force. If the pulley is allowed to move, you achieve a mechanical advantage of 2.
What is the interference of light?
We've explored wave interference before in the waves chapter. The key to the interference of light is that the two or more waves interfering must have the same wavelength and phase. While interference can be seen with ordinary light, interference is most easily seen using laser light. If light from a laser passes through two slits that are a small distance apart, the diffraction patterns from the two slits will overlap. When they do, a pattern of light and dark bands will be seen. The bright bands are where waves from the two slits are constructively interfering. The distance the light has traveled from the two slits will be equal, or they will differ by an integer number of wavelengths. The dark bands occur when the waves destructively interfere. In this case, the difference in distance light from the two slits will have traveled will be an odd number of half wavelengths. That is, 1/2, 3/2, 5/2, etc. Light can also interfere if it is reflected off two closely spaced interfaces, like the two surfaces of a soap bubble or oil film.
What does the car interact with?
When it is not moving, it is touching the road, and thus interacting with it. When you press on the accelerator, the engine causes the wheels to rotate in a direction that, because of friction between the tires and the road, pushes backward on the road. By Newton's third law, then, the road pushes forward on the tires and the car accelerates in its forward direction.
What is a white light?
The combination of all the colors in the visible spectrum.
What did Einstein do to win worldwide fame?
By 1914, Einstein's accomplishments were well accepted by physicists and he was appointed professor at the University of Berlin and made a member of the Prussian Academy of Sciences. Einstein published the general theory of relativity in 1916. Among its predictions was that light from a star would not always travel in a straight line, but would bend if it passed close to a massive body like the Sun. He predicted a bending twice as large as Newton's theory predicted. During a 1919 solar eclipse, these theories were tested and Einstein's prediction was shown to be correct. The result was publicized by the most important newspapers in England and the United States, and Einstein became a world figure. In 1921 he won the Nobel Prize in Physics as a result of his work on the photoelectric effect.
What's a watt?
Suppose you climb the stairs to the second floor. Whether you run or walk, because you have gone up the same distance, the increase in the gravitational field energy will be the same. The difference is the rate at which the energy has changed. The rate, the change in energy divided by the time taken, is called power. Power is measured in the unit called the watt. 1 watt, W, is 1 joule, J, per second, S. A kilowatt is 1000 watts or 1000 joules per second. Scottish inventor James Watt came up with the term horsepower, which is equal to 746 watts. The amount of energy it takes an average horse to pull 33,000 pounds of coal 1 foot in 1 minute. Automobiles can accelerate from 0 to 60 miles per hour, but the more powerful ones can do it in 6 seconds or less, while ones with less powerful engines may take more than 10 seconds.
Do the masses of the quarks add up to the mass of the proton?
The mass of 2 up quarks and 1 down quark sum to 8.81 MeV/C2, and gluons are massless. But the proton's mass is 938 MeV/C2. How can that be? The remainder of the mass is due to the high energies of the quarks and gluons within the proton.
What holds a nucleus together?
Protons, all being charged positively, will repel each other. So there must be an attractive force that holds the nucleus together. The strong nuclear force acts between protons and protons. Protons and neutrons, and neutrons, and neutrons, all with the same strength. Because the strong force acts the same on protons and neutrons, the two particles are frequently lumped together under the name nucleon. While the repulsive electromagnetic force acts over long distances, the strong nuclear force only acts between nucleons that are in contact. Nucleons have angular momentum, or spin, and the strong force depends on the relative orientation of the spins. The force is stronger if the spins are in opposite directions.
How do speeds of ocean waves vary?
The speed of an ocean wave depends on the distance between two successive crests, its wavelength. The longer the wavelength, the faster the wave travels. A small surface wave, such as a ripple created by the wind, travels quite slowly because it has such a short wavelength. A swell, the larger, longer wavelength waves created by constant winds, have longer wavelengths and travel at higher velocities. The energy that the wave carries depends on the square of the height of the wave, which explains why high waves can cause so much damage to shorelines. Waves break as they approach a shoreline because the lower part of the wave moves more slowly than the top part of the wave due to increasing friction with the shallower ocean bottom.
What is quantum chromodynamics, QCD?
The theory that describes the interactions between quarks and gluons.
What is the Mach number?
Ratio of a velocity to the speed of sound.
What are composite materials?
As was mentioned above, brittle materials like concrete have larger compressive strength than tensile strength. For that reason, reinforcing bars, rebars, made of steel are embedded in concrete. The steel supports the concrete when it is under tension, reducing its tendency to crack and thus keeping it from failing. Composite materials have been used since ancient times when straw was added to clay to make bricks. The most recent composite materials use carbon fibers, less than 0.01 mm in diameter, that are light in weight. They're made of pure carbon, with very high tensile strength but low compressive strength. They are added to plastics to make them more rigid, increase their Young's modulus, without adding weight. Golf club shafts are often made of a plastic filled with carbon fibers, giving the shaft great strength with low weight. By varying the amount of carbon fibers, the flexibility of the shaft can be changed. Although it isn't really a composite, glass can be made to be less brittle. The key idea is to keep the surface under compression at all times so it won't crack. Glass sheets are made from the fluid state by cooling. If the surfaces are cooled quickly with strong blasts of air, it produces a form of glass called case hardened that was used for shatterproof lenses in eyeglasses. In the 1970s, a chemical method was invented that could be used on cold glass. It involves putting the glass into a bath of potassium salts. The potassium replaces sodium in the surface layers of the glass. The larger potassium atoms expand the surface layers so that the interior portion of the glass compresses the surface, keeping it from developing cracks.
What levels of current are dangerous?
Approximately 1 mA, 0.001 A, is enough to produce a tingling sensation. 10 mA is painful. 12 to 20 mA is enough to paralyze muscles, making it impossible to let go. 60 to 100 mA causes ventricular fibrillation of the heart. That is, the heart is beating in such a way that it cannot pump blood through the circulatory system. Greater than 200 mA causes the heart to clamp down and stop beating.
What is fluid dynamics?
Study of fluids in motion.
What are some good conductors of electricity?
In order to be an effective conductor, a material must allow the electrons to move easily throughout it. The atoms in good conductors, such as most metals, have one or two electrons that can be easily freed from the nucleus to move through the material. Water is a fair conductor, but when salt is added it becomes a better electrical conductor.
What are the bends?
Nitrogen under normal atmospheric pressure is nearly insoluble in blood. Under pressure, the solubility increases. Thus, as a diver goes deeper, the blood holds more and more nitrogen, which dissolves in the blood during gas exchange in the lungs. As the diver ascends, the pressure decreases, and hence the blood is now supersaturated with nitrogen. The supersaturated nitrogen forms bubbles as it comes out of solution in the blood, or cells. These bubbles collect in veins and arteries. They cause pain, and can rupture cell walls and block the flow of blood to cells, causing injury or even death. The best way to avoid the bends is to rise to the water surface slowly, allowing the liquid pressure from the water to gradually decrease and prevent any physical damage. Most scuba divers use nitrox that contains 35% oxygen and 65% nitrogen, rather than normal air that contains 20% oxygen and 80% nitrogen, to reduce, but not eliminate the possibility of getting the bends.
How are thermographs used?
Thermographs, which detect the amount of infrared radiation emanating from objects or regions, use colors to display the temperature on an image. Typically, red indicates the warmest temperatures, while blue indicates cooler temperatures. Thermographs are used throughout science, but are well noted for their use in detecting humans in wilderness areas, identifying areas of homes that need more insulation, and in measuring the temperature over regions of Earth.
How is an electromagnetic wave created and detected?
Electromagnetic waves are created by accelerating electrons that create an oscillating electric field. This field in turn creates an oscillating magnetic field, which creates another oscillating electric field, and so on. The energy carried by the waves radiates into the area around the moving charges. When it strikes a material whose electrons can move freely, it causes these particles to oscillate.
How was the plutonium bomb used?
The plutonium bomb, named Fat Man for its shape, was dropped on the city of Nagasaki, Japan, on August 9, 1945. It contains 6.4 kilograms, 14 pounds, of plutonium-239. About 20% fissionide. And less than 1 gram was converted into energy with the equivalent of 21,000 tons of TNT. As many as 80,000 people were killed in the attack.
What is quantum mechanics?
The field of study of atoms by themselves, as well as in molecules, liquids, and solids in which the wave nature is important is called quantum mechanics. The atoms obey the Schrödinger equation. But for any atom more complicated than hydrogen, the equation can be solved only by a computer. Using computers to solve equations, run complicated models, and simulate experiments is an important subdivision of the study of physics called computational physics, which now has equal status with theoretical and experimental physics. Some of the recent accomplishments of quantum mechanics are in the areas of condensed matter physics, or the study of solids, and atomic physics. All of the integrated circuits used in MP3 players, televisions, cameras, and automobiles are designed using quantum mechanics. They are all based on diodes and transistors, where quantum mechanics describes and explains their properties and guides materials scientists to select appropriate materials for their construction. One of the most exciting new materials is graphene, a film of carbon where the atoms are in hexagon-shaped arrays, but the film is only 1 atom thick. Graphene is being investigated as a way of constructing extremely tiny transistors, and thus powerful integrated circuits. It may also be used as a sensor to detect single atoms or molecules of selected materials, or as a transparent conductor for touch-screen computer displays. Its discoverers won the 2010 Nobel Prize From 1924 to 1925, Einstein and the Indian physicist Satyendranath Bose. 1894 to 1974, predicted that if an atomic gas were cooled enough the atoms could form a new state of matter that would exhibit quantum effects on a macroscopic scale. The first experimental confirmation of this prediction occurred in 1995 when Eric Cornell, 1962, and Carl Wieman, 1952, at the University of Colorado cooled a gas of rubidium atoms to about 1/6 of a millionth of a Kelvin. They and Wolfgang Ketterle, 1957, at MIT shared the 2001 Nobel Prize for their work. While this new state of matter, called a Bose-Einstein condensate, has no existing applications, physicists are using it to improve their knowledge of how atoms interact at very low temperatures and to explore possible future applications to atomic clocks and computers.
What is reverberation time?
The reverberation time for a sound is the time it takes for the echoing sound to diminish by a factor of 60 decibels, that is, to 1/1,000,000 of its original intensity. The longer the reverberation time, the more echoing is heard because the sound has reflected off walls and other surfaces. The shorter the reverberation time, the less echo is heard.
What is a shadow?
Areas of darkness created by an opaque object blocking light.
What is a period?
The time it takes for an oscillating object or wave to complete one full vibration. The inverse of the frequency.
What is a maglev?
Magnetically levitated trains that use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks.
Why do soap bubbles and gasoline spills create different color reflections?
Iridescence is the spectrum of colors that are produced when light hits a thin film such as a soap bubble or gasoline layer. The interference of light waves resulting from reflections of light off the two surfaces of the thin film causes iridescence. A soap bubble displays an iridescent pattern because light reflects off the front and back surfaces of the soap bubbles. As the thickness of the layer varies, the interference between the two reflections will vary, causing the color to vary. Gasoline spills are easily seen on wet roads. This is not because people spill more gas when it has rained, but is instead due to the iridescent patterns that result from light reflecting off of the top of the gasoline, and the boundary between the gasoline and water. The resulting pattern appears as the colors of the visible light spectrum in the thin film of gasoline.
Why do we see specific colors?
When we see colors, we are seeing only part of the spectrum of colors that make up white light. The rest of the spectrum is missing. Selecting the color seen can be done in three ways. You can view the object through a transparent material that transmits only some part of the spectrum while absorbing the rest. The object may be colored itself. That is, it reflects part of the spectrum while absorbing the rest. Finally, the spectrum can be physically separated, as it is by interference or by refraction by a prism or rainbow. For example, theatrical gels on spotlights produce colored effects for a stage show. Snow reflects all of the spectrum so it appears white. But green paper reflects only the green part of the spectrum. A black cloth absorbs all light, and so it appears black.
Does a mirror produce an image?
The light reflected from an object by a flat, or plane, mirror is not redirected so it will converge again. What you see when you look in a mirror is a virtual image. It is located behind the mirror. Some of the rays from the object are reflected by the mirror and enter your eye. Your eye believes that all these rays came from a single point, and that point is behind the mirror. The image isn't real, it is virtual. Virtual images can also be formed by lenses. They cannot be focused on a screen.
What materials are attracted to magnets?
Iron, nickel, and cobalt and most of their alloys are attracted to magnets. Other metals, like silver and gold, copper, tin, stainless steel, zinc, brass and bronze are not attracted. Nonmetals are not attracted. Iron, nickel, and cobalt are called ferromagnetic. All materials respond to magnetic fields, but most respond so weakly that the forces are hardly felt. Those that are repelled are called diamagnetic, those attracted are paramagnetic.
What is a superconductor?
Allow electrical current to travel without resistance, and therefore no voltage drop across them or energy loss.
What would happen if the table were replaced with a sheet of paper?
The paper might hold small stones. But with a heavy rock it would tear because it could not exert a strong enough force. The heavier the rock, the greater the force the table or floor exerts. In summary, inanimate objects can also exert forces. Forces like these, exerted by humans or tables that touch the object, are called contact forces.
How do astronomers determine the temperature of the Sun?
When iron is hot, you can feel the energy radiating from it. That radiation is in the form of infrared waves leaving the iron. When iron gets extremely hot, it produces a red glow, and when it gets even warmer, it can take on a whitish glow. The temperature of iron and other objects can be measured by the amount of radiation flowing from it as well as by the light it emits. Scientists measure the temperature of stars and the Sun by analyzing the color and brightness of the stars. From such measurements, astronomers have determined that the surface of the Sun is approximately 5,500 degrees Celsius, 9,900 degrees Fahrenheit.
Can you do it?
Standing on your toes moves your point of support in front of your center of gravity. So you will tip backwards.
Does sound's intensity always follow the inverse square law?
Sound doesn't always spread uniformly. You may have experienced this if you shout while you walk through a tunnel. You hear echoes, and a person at another part of the tunnel will hear you much more clearly than he or she would in an open area. Whispering chambers are often found in science museums. They are rooms with walls in an elliptical shape. If you stand at one focus of the ellipse and another person stands at the other focus, you can hear each other speak even if you whisper while other people in the chamber are talking loudly. Sound can also be transported through the ocean with less spreading using an acoustic waveguide. Similar to the way light can travel in an optical fiber, see the chapter on light. The ocean water can separate into layers at different temperatures. The speed of sound depends on water temperature, and if there is a layer of cold water where sound speed is lower under a layer of warmer water where the speed is higher, then some of the sound moving through the cold layer will be reflected at the boundary back into the cold layer, keeping it from spreading. The name of this channel is sound frequency and ranging, so far, channel. It is 100 to 200 meters below the surface in the cold waters off Alaska, but 750 to 1,000 meters deep in the warmer Hawaiian waters.
What is a parallel circuit?
Circuit allows the charges to flow through different branches.
How do you measure weight?
If you stand on a scale, the scale measures the upward force of the scale on your feet. According to Newton's third law, that force is equal to the downward force of your feet on the scale. Actually, there is a slight difference because of the rotation of Earth. If you stand on a scale in an elevator, you'll see that your weight changes as the elevator accelerates. When it is going up and increases its speed, the scale will record a larger weight. The same will happen when you are going down and come to a stop. When it slows while going up or speeds up while going down, the scale will show a smaller weight. Newton's second law can explain these changes using the fact that a net force is needed to accelerate you along with the elevator. Note that you don't really need a scale to sense these accelerations. You can feel them in your stomach.
What are vocal cords?
Or vocal folds. Vibrating source of the human voice.
What is the source of every sound?
Sound waves are created by some type of mechanical vibration or oscillation that forces the surrounding medium to vibrate. A tuning fork is an excellent example of a vibrating sound source. When struck by a rubber mallet, the tines of the tuning fork vibrate, causing the air molecules around them to move back and forth at the same frequency, creating areas of compressions. Where the molecules are close together and air pressure is slightly increased. And rarefactions, where the molecules are spread apart and thus the air pressure is reduced. These pressure changes then move away from the tines, creating the longitudinal sound wave.
What is an apparent weightlessness?
Occurs when an object is in free fall. Force on object in direction opposite gravity is zero.
Which car has the larger acceleration?
Both have the same change in speed. But the sports car requires less time to make the change, so it has the larger acceleration. Like velocity, acceleration is a vector. That is, it includes both magnitude and direction. In speeding up, in which the change in velocity is positive, acceleration is a positive quantity. If the object is slowing down, then the acceleration is negative. If, however, the object is going in the negative direction, for example, A car going in reverse then speeding up is a negative quantity because the final velocity is more negative than the initial velocity. Physicists do not use the term deceleration. Whether positive or negative, speeding up or slowing down, the term acceleration is always used. The table below shows some typical accelerations in a variety of units. The rightmost column, labeled g, compares the acceleration to that of an object falling in Earth's gravitational field. This ratio is frequently used in both everyday and scientific writing.
What is an inertial confinement?
Method of producing nuclear fusion by using lasers to compress tiny amounts of a deuterium-tritium fuel mixture.
What are transformers?
An impedance matching device is called a transformer. Instead of an abrupt change between the two media, a transformer provides a smoother, gradual transition from the old to the new medium. Depending upon the wave and the medium, different transformers, such as quarter wavelength and tapered transformers, can be used to help minimize reflection. An example of a tapered transformer can be found in soundproof rooms or sound studios. Any sound that is produced is supposed to be absorbed by the impedance matching material on the walls. Special foam, tapered in a V-like shape, is used as a transformer to gradually absorb all the sound into the walls. The gradual changeover from the air medium to the wall medium prevents sound from reflecting back into the air. An example of a quarter wavelength transformer can be found on many camera lenses and eyeglasses. The quarter wavelength thick coating on a lens is used to reduce reflections off the lens surface, allowing more light into the lens. Electrical transformers are also used to match impedances by changing the varying voltages and currents in an electronic circuit. Modern electronic circuits make very minimal use of transformers because of their weight and size.
What are cathode rays?
Electron beam in an evacuated glass tube.
What is a calorie, cal?
A unit of energy that is used both to measure both thermal energy and heat.
What is a gigahertz, GHz?
(1,000 million or 1 billion hertz).
Who introduced the modern chemical symbols?
Swedish chemist Jöns Jacob Berzelius, 1779–1848, introduced the modern chemical notation using one or two letters to represent an element in 1813. Rather than today's notation for water, H2O, Berzelius wrote H2O. Berzelius did much more. He published the first accurate list of the weights of atoms.
What is an open circuit?
A circuit is a closed loop through which electric charges can flow. If the loop is opened, then it is called an open circuit and charges no longer flow. A switch is commonly used to open and close a circuit. If a wire breaks, the connection between the wire and another part of the circuit fails. Or if a lamp burns out, its filament breaks, then the circuit is opened and there is no current.
What is a standing wave?
The example used above showed what happened when two single waves going in opposite directions met. A continuous wave is a set of single waves, one after another. You can produce such a wave by shaking one end of a rope up and down at a constant frequency. Now, if the other end of the rope is tied to something that doesn't move, the wave will be reflected back toward you. If you shake the rope at the correct frequencies, the two waves will overlap each other and will seem to stand still, producing a standing wave. Two distinct regions on a standing wave can be seen. At certain points the rope won't be moving. That point is called a node. The point where the motion of the rope is largest is called the antinode. The nodes are locations of destructive interference where the two waves moving in opposite directions have opposite amplitudes. The crest of one wave and the trough of the other are at the same location. The antinodes are at locations of constructive interference where the two waves have both positive or negative amplitudes, that is, both are either crests or troughs. The frequencies that produce standing waves depend on the length of the rope and the velocity of the wave on the rope. The lowest frequency will have nodes at the two ends and an antinode in the center. The next higher frequency will have a node in the center and ends and two antinodes. At each higher frequency the number of nodes and antinodes increases by 1.
What is a sonic boom?
Caused by a shock wave produced when an aircraft reaches the speed of sound.
Are emission and absorption the only ways light interacts with an atom?
In 1917 Albert Einstein proposed a third way light could interact with an atom. if a photon with the correct energy struck an atom in the excited state, then the atom would be stimulated to emit an additional photon and drop to the lower energy level. The two photons leave with the same energy, in terms of a wave, same wavelength, and in phase.
What is the dark energy?
Said to be cause of accelerating expansion of universe. Comprises 72% of mass and energy of universe. Its nature is totally unknown.
What makes up the nucleus?
Ernest Rutherford, 1871 to 1937, had determined that the charge on the alpha particle, actually the helium nucleus, was 2 proton charges, but its mass was 4 proton masses. Dmitry Mendeleev, 1834 to 1907, in building the periodic table, had arranged the elements in order of their mass and had arbitrarily assigned them sequential numbers that he called the atomic number. The English physicist Henry Moseley, 1887 to 1915, measured the wavelengths of X-rays emitted when metals were struck by other X-rays. He was able to provide a physical basis for the atomic number and, in doing so, greatly strengthened the case for Rutherford's nuclear model. But, as is the case for helium, if the atomic number, and thus the nuclear charge, was about half the atomic mass number, what made up the additional mass of the nucleus? The first proposal was that the missing particle was a combination of a proton and an electron, which would have the correct mass and charge. But the Heisenberg uncertainty principle showed that if an electron were confined to the size of a proton, its energy would be larger than ever observed. In addition, by the late 1920s the angular momentum of the nitrogen nucleus, with charge 7 and mass 14, had been measured. The result could not be obtained from a combination of 14 protons and 7 electrons. In 1931 two German physicists found that when energetic alpha particles struck light elements, a very penetrating, neutral radiation was produced. The next year Marie Curie's daughter, Irene Joliot-Curie, 1897 to 1956, and her husband, Frederick, found that if this radiation struck paraffin, protons were ejected, suggesting that the radiation was actually a neutral particle with a mass near that of a proton. The next year James Chadwick, 1891 to 1974, working in Manchester, England, experimentally confirmed the suggestion. The particle was named a neutron, combining neutral with the ending of the word proton. He was awarded the Nobel Prize for his discovery in 1935. The neutron has a mass slightly larger than that of the proton. While neutrons are stable in non-radioactive nuclei, if they are free from the nucleus they decay with a half-life of about 10 minutes. Neutrons are used extensively in creating nuclear reactions and are necessary for nuclear fission, which will be discussed later in this chapter.
How does an FM band station transmit stereo sound?
Stereo sound means that two separate sounds, the left L and right R, are produced from a pair of speakers. Because stereo broadcasts must also be usable by receivers that cannot reproduce stereo, the signal that all receivers can detect consists of the sum of the left and right channels, R and L. The difference of the two channels, R, L, is broadcast 38 kHz above the R and L signals. Mono receivers can't detect these very high frequencies. The stereo receiver, though, can, and from the R and R, L signals creates separate R and L signals to be amplified and sent to the corresponding speaker. FM stations have enough bandwidth to accommodate a third signal. This signal can be sold to users to provide background music for stores or elevators. Education stations can deliver lessons to schools, or broadcasts in a second language.
What is hydraulics?
Use of a liquid in a device, usually a machine such as a pump, lift, or shock absorber.
What is convection?
The motion of a fluid, usually air or water, due to a difference in temperature. An efficient means of heat transfer.
What is the Nobel Prize?
The Nobel Prize is one of the most prestigious awards in the world. It was named after Alfred B. Nobel, 1833 to 1896, the inventor of dynamite. He left $9 million in trust, of which the interest was to be awarded to the person who made the most significant contribution to their particular field that year. The awards, given in the fields of physics, chemistry, physiology, and medicine, literature, peace, and economics, are worth over $1,400,000, and a great deal of recognition.
What is the tallest building in the world?
The tallest building, until recently, was the Sears Tower, now the Willis Tower. In Chicago, Illinois, which was built in 1974 and is 443 meters, 1,453 feet, high. 3 new skyscrapers in Asia now surpass this height. The Petronas Towers in Malaysia, completed in 1996, are 452 meters, 1,483 feet, Hi. The Shanghai World Finance Center in China, completed in 2008, stands 492 meters. 1,614 feet, high, almost half a kilometer into the sky. The Burj Dubai, Dubai Tower, 818 meters, 2,684 feet, high, the world's highest, opened in January 2010.
What is a solar eclipse?
An eclipse of the sun occurs when the moon casts its shadow on Earth. As the moon moves between Earth and the sun, darkness falls upon the small part of Earth where the moon blocks the light.
What is acceleration?
Speed and velocity are seldom constant. Usually they vary, and acceleration is a description of how that variation occurs. Acceleration is called the time rate of change of velocity. That is, it is the change in velocity divided by the time over which the change occurs. For example, a car might accelerate from 0 to 60 miles per hour. A sports car might do this in 5 seconds, while an economy car might require 9 seconds.
What is electricity, resonance?
Produced when plastic, amber, or sealing wax is rubbed.
How is a camera similar to, and different from, the eye?
A camera performs many of the functions of the eye. It has a lens to form an image on a photosensitive surface. The lens must be able to form sharp images of objects both close and far away. The amount of light reaching the photo detector must be controlled to make the exposure correct. In older cameras, the photosensitive surface was film. Today cameras use a digital sensor. These sensors are small, most are between 3/8 and 1 in size but contain as many as 10 million separate light detectors called pixels. Each pixel is covered by a red, green, or blue color filter so the camera can produce full-color images. A camera's lens isn't flexible like the one in the eye, but the distance between the lens and the sensor can be varied. Bringing a distant object into focus requires that the lens be closer to the sensor. A close object requires that the lens be moved further away. The amount of light is controlled two ways. One is to have an aperture that can be opened to admit more light or closed down to reduce the amount of light. The second is a shutter that controls the amount of time light is allowed to reach the sensor, while leaving the sensor exposed for a longer amount of time is needed when the light is dim. It also will cause a blurred image if the object is moving. Thus it is important to select the correct combination of aperture and shutter speed to take good pictures.
What would happen if the cable holding the elevator would break?
You and the elevator would both be in free fall, accelerating at g. There would be no weight shown on the scale. You and the elevator would both be in the state of apparent weightlessness. We'll meet this term again when we explore the motion of satellites. The apparent weightlessness of astronauts will be explained there.
What are the average surface temperatures of the planets in our solar system?
For the planets that have atmospheres, mixtures of gases surrounding the surface of a planet, the average temperature stays relatively constant because the atmosphere acts as a type of insulator. These planets have only small variations in the temperature. When a section of the planet faces away from the Sun, Mercury, on the other hand, with no atmosphere and an elliptical orbit, has very large differences. In the table below, the temperatures of Mercury, Venus, Earth, and Mars are taken on the planetary surface, while those of Jupiter, Saturn, Uranus, and Neptune are taken at the tops of the clouds, there being no solid surface on these planets. This plasmolampin apparatus you often see at science fairs and novelty shops emits streams of plasma, electrically charged particles that are found in everything from stars to television displays and fluorescent lights.
What is entanglement?
Consider what happens when a positron and electron annihilate. Two gammas, high-energy photons, are produced that go off in opposite directions, 180 degrees apart. They can be detected many meters from their source and have opposite spins. But which gamma has which spin is a random choice. That is, for each gamma there is a 50/50th chance that it will be in a particular direction. Suppose you find that the spin of one gamma is pointing up. But, the moment you detect the spin of that gamma, the spin of the other gamma must be pointing down. The result of one measurement determines the results of the other. The two detectors would measure the spins of their gammas at the same time. So there is no way that one gamma could communicate with the other gamma. Physicists say that the spins of the two photons are entangled and that the spin state of each photon is the superposition of the two possible spin directions. When the spin is measured, the wave function collapses and gives a definitive result. Albert Einstein, 1879 to 1955, called results like this spooky action at a distance. Others have called it quantum weirdness. Similar results can be obtained with atoms or ions, in which case the photons are light quanta and may be transported through space, or the air, or by optical fibers. For example, if an atom is excited by the absorption of a photon, it can emit two photons that are entangled the same way the gammas are in the example above.
Are other muscles and bones in your body so easily characterized?
Most are not, because tendons that transmit the force from the muscle to the bone are long and go through several bends. Consider sports equipment like baseball bats, tennis rackets, and golf clubs. They are often used as extensions of your arms. So the person plus the bat or club has to be examined together. But note that in every case the SYSTEM is a third-class lever. Where a large distance moved, and therefore greater speed, is favored over an increased force.